New internal documents from the FIA have revealed that Lewis Hamilton's Ferrari is now under a serious technical investigation after his shocking performance collapse in Qatar. The evidence shows behavior inside the SF25 that engineers could not explain during the race, and that forced Ferrari to brake park firm just to keep the car stable enough to compete. These findings suggest that Hamilton was not simply slow, but driving a machine suffering from structural aerodynamic misalignment that could threaten the final race of the season. Before we reveal the full details of what the FIA found inside Hamilton's Ferrari, make sure you subscribe, because what happens next in Abu Dhabi may define his entire first year in red. Hamilton's Qatar Grand Prix exposed the deepest technical crisis Ferrari has faced in years. From the moment he left the garage on Sunday, the SF25 behaved like a car disconnected from itself, incapable of generating stable downforce through the fast corners of Lusail. The team had already identified an aeromechanical mismatch between the floor and the rear suspension, but the scale of the problem only became fully visible once Hamilton pushed on heavy fuel. The car snapped unpredictably on exit, understeered heavily on entry, and reacted to bumps with violent bouncing reminiscent of the porpoising era. Ferrari entered the race knowing they had no pace to fight the leaders, but they did not expect the deficit to stretch beyond 1 second per lap. Hamilton started from 17th position after the team broke park firm, trying to rescue balance. Yet even with fresh settings, he reported within the first laps that keeping the car on track required a level of concentration far beyond normal race conditions. His words, "This is a fight you would not believe," reflected a driver working to avoid spins rather than chasing lap time. The opening stint confirmed that the SF25 lacked mechanical grip, aerodynamic stability, and straight-line consistency. The FIA investigation was triggered by a series of telemetry behaviors that did not match Ferrari's declared setup parameters. The rear suspension movement showed micro-oscillations inconsistent with the permitted range, and the aerodynamic load variation across sectors 2 and 3 did not align with any documented configuration. While no illegality has been suggested, the FIA wants to determine whether Ferrari's correlation problems are causing structural instability that may violate safety standards under prolonged high-speed load. Hamilton's repeated complaints about bouncing under braking at turn 10 increased the urgency of that review. Radio communication throughout the race revealed the level of frustration inside the cockpit. Mid-race, Hamilton reported that the rear end was going everywhere, and that the changes the team made had somehow made the situation worse. By the final laps, his tone shifted from frustration to resignation. He crossed the line in 12th place and said only that the car had no speed. Behind those words was a deeper message. The 7-time champion understood that the SF25 was fundamentally flawed and that no amount of setup work could rescue its lack of stability. Charles Leclerc's race confirmed the scale of Ferrari's structural issues. Even with cleaner air and fewer battles, he could only salvage a single point in 10th place, benefiting from incidents rather than pace. He described the car as slow, unstable, and embarrassing when compared to midfield teams like Alpine and Williams. Both drivers agreed on one thing. The SF25 lacked mechanical grip, lacked aerodynamic consistency, and lacked any competitive tools required to fight the front of the grid. Their comments created the internal pressure that triggered Ferrari's post-race technical review. Team principal Fred Vasseur attempted to shield the drivers by taking public responsibility. He admitted that Ferrari's decision to halt development in April left the team exposed during the final phase of the season. By shifting resources to the 2026 project, Ferrari had effectively locked Hamilton into a car with known problems and no planned upgrades. He criticized the broadcasting of selective radio messages that suggested driver conflict and emphasized that both Hamilton and Leclerc were united in their assessment. The problem was not the drivers. The problem was the car. The FIA investigation now focuses on understanding why the SF25 generated such unpredictable aerodynamic behavior and whether deeper structural weaknesses contributed to its instability. Qatar confirmed that Hamilton's first season in red has been defined by a machine incapable of competing at the required level. 12th place was not a poor performance. It was the inevitable result of a car fundamentally disconnected from its design targets. Unless Ferrari solves the mystery uncovered in Qatar, Hamilton faces the prospect of ending the season with another weekend of suffering in Abu Dhabi. The root of Ferrari's crisis in Qatar was visible from the opening laps when the SF25 showed behavior completely disconnected from the expectations created in the simulator and the practice sessions. Hamilton struggled to keep the car stable even on high fuel, reporting that the rear end was stepping out without warning at medium speed. That level of instability is not a simple balance issue, but a deeper structural problem involving aerodynamic load distribution. The car behaved as if downforce was shifting unpredictably from the rear axle to the floor, creating a sense of floating that Hamilton could not control. From the very start, Ferrari no longer had a race to manage. They had a disaster to survive. A second layer of the problem appeared when Hamilton confirmed through radio messages that the bouncing under braking was getting worse. Bouncing in this context does not refer to porpoising, but to a micro-oscillation created when the suspension cannot synchronize with aerodynamic load transfers. Once this begins, the car loses contact consistency with the track surface, and the tires struggle to maintain grip. The impact is brutal for confidence. A driver cannot attack corner entries when the car behaves as though it has two different aerodynamic profiles depending on the level of lateral load. Hamilton described it as fighting something you would not believe, a sentence that broadcast the severity of instability he was dealing with. The third component of the problem came from the decision to brake park firm. In Formula One, that choice is never taken lightly. It requires acceptance that the qualifying setup is fundamentally unusable for race conditions. By opening the car and modifying the parameters, Ferrari forced Hamilton to start from 17th position. Even with fresh adjustments, the underlying issues remained unresolved. This confirmed that Ferrari's correlation errors were not limited to balance, but extended to the structural connection between the floor, diffuser, and rear suspension. Once that connection fails, the car loses aerodynamic predictability and becomes impossible to correct within a single race cycle. The fourth part of the problem involved the enormous gap between Ferrari's expectations and the actual pace of the car. From the early season until the Qatar event, Ferrari believed the SF25 had a stable performance window, even if it lacked the highest ceiling. Instead, Hamilton found himself losing more than 1 second per lap to the leaders. In modern Formula One, that margin is catastrophic. It indicates that the car is not simply slow, but fundamentally misaligned with the demands of the circuit. Lusail's layout magnifies weaknesses in aerodynamic efficiency and mechanical rotation, and the SF25 suffered heavily in both categories. A fifth element of the problem came from the effect this instability had on tire management. Hamilton's car was sliding on corner entry and snapping on exit, two behaviors that destroy rear tire life. The engineers attempted to stabilize temperatures through brake adjustments, differential changes, and energy deployment management, but none of these levers can fix a structural aerodynamic imbalance. As a result, Hamilton could not use the tires aggressively enough to generate pace, yet still experienced degradation similar to cars pushing far harder than he was. This combination locked Ferrari into a race where recovery was mathematically impossible. A sixth layer of the problem was the emotional impact on both Ferrari drivers. Hamilton's radio messages grew more resigned with every lap. He said the car was going everywhere, and later admitted it had no speed at any point. These were not the comments of a frustrated driver, but of a champion recognizing that the machinery beneath him was incapable of meeting even baseline performance expectations. Leclerc experienced similar issues, describing the car as slow and unstable while barely salvaging 10th place. These parallel observations confirmed that the problem was not driver-specific, but systemic across the entire Ferrari package. The final part of the problem became the reason the FIA initiated an internal probe. Telemetry inconsistencies in load transfer behavior suggested that the SF25 may have been operating outside Ferrari's declared aerodynamic model. The investigation is not aimed at punishment, but at understanding whether structural weaknesses in the floor or suspension created unpredictable behavior that could compromise safety under prolonged high-speed load. Hamilton's complaints about instability at turn 10 and bouncing under braking gave the FIA sufficient reason to examine the car closely. The Qatar weekend revealed that Ferrari did not simply experience a bad race. They encountered a fundamental breakdown in correlation between design targets and real-world performance, leaving Hamilton with a machine he could not compete with. Ferrari's engineering department faced severe pressure from the moment Hamilton completed his first laps on Sunday. The telemetry exposed a car that was not responding to any of the pre-race expectations established in simulation. The SF25 showed inconsistent aerodynamic load during medium speed corners, with the floor producing fluctuating downforce values that the rear suspension could not stabilize. Engineers realized immediately that they were not dealing with a normal performance deficit, but with a structural behavior issue. Their priority shifted from performance development to ensuring Hamilton could handle the car safely for a full race distance. One of the earliest engineering challenges came from the braking instability Hamilton repeatedly reported. The car bounced entering turn 10 because the suspension frequency did not match the aerodynamic load transfer at high speed. Ferrari's engineers attempted to soften the effect by modifying brake migration and adjusting the brake by wire behavior to create smoother transitions under deceleration. However, these adjustments could not correct the underlying problem. When the front and rear axles do not share a unified aerodynamic platform, the car reacts differently every lap, making consistent braking almost impossible for the driver. Another layer of pressure came from a need to manage tire degradation, while Hamilton struggled with sliding and snaps. The SF25 consumed its rear tires faster than expected because instability forced Hamilton to compensate with steering corrections and throttle modulation. Engineers tried to manage tire temperatures through differential settings, corner entry instructions, and energy deployment changes. Still, they could not stabilize the thermal behavior because the structural aerodynamic imbalance meant the tires were constantly overloaded in unpredictable phases. The team understood that tire management had shifted from an optimization task to damage control. Ferrari also had to manage an unexpected aerodynamic variation across sectors. The telemetry showed that the car behaved relatively stable in the opening corners, but deteriorated rapidly in the middle sector, particularly through the long radius curves where consistent floor load is essential. Engineers analyzed wind direction, speed, and ground effect variations, but the behavior remained inconsistent. This forced them to give Hamilton highly specific corner-by-corner instructions to help him adapt dynamically to a car that was not delivering uniform downforce. Even with those adjustments, the SF25 refused to produce a predictable aerodynamic profile. Energy deployment added another major challenge. With the SF25 lacking straight-line efficiency and mechanical grip, engineers needed to find a deployment pattern that allowed Hamilton to defend when necessary while still protecting battery reserves. He received instructions to modify harvesting zones and adjust throttle lift points to maintain charge. However, because instability forced him to use more throttle corrections mid-corner, energy management became far more difficult. The engineers had to constantly recalculate deployment strategies to match the unpredictable flow of the race, making energy control one of the most stressful aspects of the afternoon. A further source of engineering pressure was Ferrari's decision to brake park firm. Once the car's setup was opened, the team had to rebuild a baseline configuration without the benefit of fully correlated data. They made mechanical changes to stabilize balance, but these adjustments were educated guesses rather than precise solutions. The result was a car that behaved differently from expected model, but still carried the same instability patterns that had ruined qualifying. Engineers were forced to accept that their intervention had prevented a worse disaster, but had not created a competitive platform.